To enforce standards across a food safety enterprise, regulators currently rely on physical audits. An inspector arrives, observes the floor for a few hours, logs the infractions, and leaves. This method leaves massive observational gaps. Critical violations, like cross-contamination or improper temperature holds, often occur in the days and weeks between these manual visits, going completely undetected. Closing these gaps requires continuous AI oversight, using computer vision to monitor facilities 24 hours a day and identifying issues the moment they arise. The primary engineering roadblock to this level of visibility is data transmission. Attempting to stream continuous 1080p video from 50 cameras across 1,000 distributed sites would immediately overwhelm the network. The Infinity Command Platform bypasses this bottleneck by operating as a hybrid edge cloud orchestration layer rather than a simple streaming service. By restructuring how data is processed, the platform achieves sub-5-second latency and 99.5% uptime while reducing cloud bandwidth consumption by over 95%. Overcoming this bandwidth constraint is the foundational requirement. Without it, real-time regulatory enforcement at an enterprise scale is physically impossible. To avoid saturating the network, an edge computing gateway is installed on site. This node intercepts raw, high-definition camera feeds directly from the facility's local network. This node performs all computer vision inference locally. If an employee is following proper protocols, the system discards the footage immediately rather than sending it to the cloud. Raw video hits a base model layer, mapping human skeletal points to create a wireframe of the activity. This data then branches into fine-tuned models trained for specific violations, like identifying bare hands touching ready-to-eat food or missing protective equipment. To analyze complex actions over time, the node employs a slow-fast architecture. This allows the system to calculate the exact duration of an event across multiple frames, verifying that a hand-washing sequence lasted the required 20 seconds. When the models algorithmically confirm a violation, the edge node isolates only the specific 10 to 20-second incident clip for transmission. A continuous 1080p stream would consume megabytes of data every second. This isolated evidence package is a tiny fraction of that size. Shifting inference to the edge and extracting only microclips allows an enterprise to scale to thousands of cameras without hitting a bandwidth ceiling. Visual data alone cannot verify every physical state. A camera can see a freezer door is shut, but it cannot confirm the internal temperature or detect a drainage blockage. This requires the integration of IoT sensors, like thermometer probes and moisture sensors, which stream data directly into the edge gateway. This telemetry flows into a partitioned database designed to handle high-volume time series analysis without slowing down the network. The alert rule engine fuses these streams, combining visual bounding boxes with temperature trend lines. This allows for compound conditions, triggering only if the temperature stays above -10 degrees for 120 minutes, preventing false alarms from a door briefly opening. Fulfilling these specific parameters automatically maps the event to a predefined regulatory severity scale. A P1 critical threshold might trigger an immediate emergency alert, while a P3 moderate threshold is simply logged for a weekly compliance report. Sensor fusion links isolated, circumstantial data points to provide legally defensible, multidimensional evidence. At an enterprise scale, even a small false positive rate creates alert fatigue. If inspectors are flooded with bad data, they will eventually stop responding to the system. The first layer of suppression is spatial filtering. The system uses zone-based rules to ensure an alert only triggers when an action occurs inside a defined prep zone, ignoring the same activity in non-regulated areas. Next, a multi-frame confirmation requirement rejects momentary visual anomalies. The engine requires sustained detection over several consecutive seconds before validating the event. High-frequency events are passed through the intelligence-to-duplication service. It uses a 5-component fingerprint to consolidate repeated, identical violations occurring in the same location into a single incident file. The final programmatic gate is the model's confidence threshold. The detection must clear a specific mathematical score before an alert is ever generated. If an error does make it through, a human-in-the-loop mechanism allows operators to flag the false positive, which then triggers an automatic model retraining pipeline. This aggressive suppression protects the integrity of the regulatory signal, ensuring that every alert represents a genuine threat. When a validated event reaches the cloud layer, the platform immediately generates an immutable audit trail that cannot be altered or deleted. To maintain privacy and security, the database uses row-level security to ensure that data from one facility is never accessible to another. The webhook dispatcher service then packages this data for transmission to external government authorities. The outbound payload includes the event type, the 92% confidence score, and direct links to the isolated video evidence. The dispatcher applies a cryptographic signature, ensuring the evidence is locked and tamper-proof before it moves across the network. This secure payload is then routed directly into the government's external inspection system. If the receiving server is down, an exponential back-off retry logic ensures the package is continually redelivered until receipt is confirmed. This automated dispatch instantly translates a physical safety violation into an actionable government case without a single human data entry. Zooming out from the individual payload, regulators now have a macro view of the entire food safety ecosystem. Executive dashboards distill millions of telemetry points into simple risk heat maps, allowing leadership to see where violations are most likely to occur. This architecture cuts the mean time to acknowledge a P1 critical violation down to under 15 minutes. This 15-minute response window eliminates the weeks of unmitigated risk that defined the manual inspection model. Constant oversight is finally possible at scale because edge processing removes the bandwidth roadblock. Accuracy is maintained because the fusion of visual AI with IoT sensors provides multi-dimensional proof for every alert. From the physical action on the floor to the secure government dispatch, the entire loop creates an unbroken SLA-backed chain of evidence. Intelligent local filtering and compound data orchestration make scaling AI compliance possible without the limitations of brute force cloud storage.